Okay, so question 45, draw curved arrows to show the flow of electrons. So first off, take a look at this um, overall reaction structure that I've drawn out and see if you can figure out where my mistake is. There's a mistake somewhere in the setup. Okay, so hopefully you would have recognized that I don't have charge balance on this equation. So on the right-hand side of the equation, there's an overall charge of -1, and on the left-hand side, it's an overall neutral. So there's something weird with what I've drawn. So I made a mistake in calculating formal charge somewhere. And the obvious issue here is going to be with this oxygen on the top right. So if you do a valence charge calculation, you'll find out that this oxygen should be negatively charged. And what we're going to try to do here is we're going to try to end up breaking one of these carbon-oxygen bonds. So this oxygen right here, hopefully you can see this, but if not, I'm going to spell out exactly where everything is. So this red oxygen right here is going to end up being this oxygen right there. And this yellow oxygen is going to end up being this oxygen right here. And then we're going to have a couple of CH3s. So this CH3 is this CH3, or this one, doesn't really matter. They're both exactly the same. They're both CH3s. I'm just going to designate them just to make sure everybody can see where the two of the methyls are going. And the third methyl is actually still going to end up being attached to this yellow oxygen right here. Okay, so what's going to happen is that we're going to end up breaking this oxygen-carbon bond, and we want to end up forming another pi bond between this oxygen and this carbon. So what we're going to do is we're going to end up using one of these lone pairs to do that. So we're going to take this lone pair, push it onto the carbon-oxygen bond, and then after that we're going to end up breaking this carbon-oxygen bond. So we're going to break this guy. And so we're doing this for two reasons. One is because obviously we have two products, and the second reason is that we don't want to have a Texas carbon right here. So if I didn't break this bond, this carbon would have ended up having 5 bonds to it, which again is technically impossible for this carbon. Okay, so that's the curved arrows for this sub-question A. There are two more questions, or two more sub-questions, sub-question B and C. See if you can figure those out on your own, and if not, ask me about them and we'll chat about it.